As the door slides shut and silence falls, it's my pleasure to welcome you all. My name's Ivan Gaskell. I'm on the faculty here, and I'd like to welcome you on this snowy evening. You made it. I hope you make it home. I'd like to welcome you on behalf of the director, Susan Weber, and our dean, Peter Miller. I'd like to welcome those also who are attending at a distance via the Bard Graduate Centre's online video streaming BGC TV. You see a reference to it up there. When we come to the discussion period, those who are attending remotely will have the opportunity to send questions via the BGC Twitter feed. And I have a device here which I'm told will allow me to read any questions that come. I'm not familiar with such things, but anyway, we'll experiment if necessary. So this evening's event is in the series Conservation Conversations, and I have to say that slowly, which is part of the BGC's Cultures of Conservation initiative, undertaken with the very generous financial support of the Andrew W. Mellon Foundation. Now, the Andrew W. Mellon Cultures of Conservation initiative here at the Bard Graduate Centre seeks to enhance connections between conservators and conservation scientists on the one hand, and scholars in the human sciences on the other, in order to promote interdisciplinary dialogue. And we hope especially to benefit the next generation of emerging scholars and practitioners through curricular development. The initiative has allowed us not only to schedule events such as this evening's, but several visiting positions for faculty and postdoctoral fellows who enhance our teaching and research in this field. Now, this evening's conversation is under the title Knowledge in the Making: Reconstructing Historical Materials and Techniques. Pamela Smith and Andrew Lacey will talk about their work to reconstruct early modern European mold-making and metal casting techniques, as well as their collaboration to reproduce technical processes from a 16th century compilation of technical recipes. They're going to discuss how such reconstructions can be integrated into research and teaching. And I must say it's wonderful. Dean Miller pointed out to me just a few moments ago that we have here an academic and a maker actually together in the same room, working together, and this is something I think that's very special for this whole undertaking of this program. Now, this is a return visit for Pamela Smith, for she participated in the panel discussion "The Future of Making and Knowing" here at the BGC just last month. And this evening's exploration is in many ways closely related to that project, exemplified in the book it celebrated, Ways of Making and Knowing: The Material Culture of Empirical Knowledge. And this explores the proposition that making art can constitute a means of establishing knowledge claims about nature. This proposition underlies the discussion this evening of the production of metal sculpture in Europe in the 16th century. I shall briefly introduce both speakers now, and I mean briefly, and each will give a presentation. Pamela Smith she told me about 20 minutes, and Andrew Lacey a little longer than that. But in total, you will be riveted, I can assure you. And then we'll join in conversation in which you're all invited to participate. So Pamela Smith is the Seth Lowe Professor of History at Columbia University and director of the Making and Knowing Project. Professor Smith specializes in early modern European history and the history of science, and her current research focuses on attitudes to nature in early modern Europe and the scientific revolution, with particular attention to craft knowledge and historical techniques. And she is founding director of the Center for Science and Society at Columbia. Andrew Lacey is a sculptor and an independent scholar who specializes in research on European Renaissance bronzes. His particular approach to making sculpture and exploring the nature of materials is influenced by both historical and archaeological study. So this is, I think, a wonderful pairing that will take us into the heart of the relationship between art making and character, the certain aspects of the character of nature. So I will invite Professor Smith to come to the lectern and present on these wonderful and extraordinary things.
Thank you. Thank you very much, Ivan. I very much appreciate coming back to the Bard Graduate Center and especially working with Andrew and Sean in the lab. And you will hear much more about the lab in just a minute. I am going to give a quick context to our collaboration. And our collaboration has, in some ways, gone on for many years because I am such an admirer of Andrew, and I worked very briefly with him and Francesca Baver in a bronze casting, when they put on a historical bronze casting course. But Andrew has just arrived yesterday for his time as an expert resident maker in the lab, and so we are now working together in both teaching the course and exploring some of these techniques. So let me give you a little bit of context to our work. If you know my last book, The Body of the Artisan, you know that I was interested in life casting in it because I think that it is a way that life casting is a way, as other kinds of very naturalistic representations of nature, is an artisanal claim to knowledge of nature. This is a philosophical object or an epistemic object. And the kind of claim that's made in this is that an artisan like Bernard Palissy in the 16th century could have as certain knowledge, access to as certain knowledge as the abstract knowledge of mathematics. It was certain because he could make this incredible representation of nature. Here is another example of casting from life by Wenzel Jamnitzer, the master goldsmith of Nuremberg. And as I investigated casting from life, I came to know this manuscript, which is held in the Bibliothèque Nationale in Paris. It is a compilation of technical recipes. It's a very intriguing manuscript. It is certainly compiled, written down in between 1580 and about 1650. And it gives very precise instructions for casting from life. Not in a linear manner, in a very looping manner, but it has castings from life, for example, like the 16th century life castings at the Germanisches Nationalmuseum. Wenzel Jamnitzer, this was his specialty. You can see the bouquet in the back of his portrait. And here is one of his pieces, 1549, that's now in the Rijksmuseum in Amsterdam. It is part of this about 3-foot-high table piece. Now, casting from life was accomplished by taking plants or recently killed animals, posing and then molding them in plaster, burning out, then pouring molten metal into the hollow left by the animal or plant. And this technique, as you can see, resulted in a very precise representation of the cast creature or plant. Life casting was especially favored for animals that inhabited more than one elemental zone within the early modern view of the cosmos, such as lizards, snakes, crabs, frogs and crayfish, toads, which lived both in earth and water, as well as birds, and many insects which inhabited, of course, both air and earth, and were, of course, associated with fire as well. Now, these kinds of objects were kept in noble collections. Here are a few more of the incredible life castings on the writing box that's attributed to Wenzel Jamnitzer in the Kunsthistorisches Museum. This is a fly. It's about half an inch long. Now, these kinds of objects were collected throughout Europe, and in the inventories of noble collections, you find literally hundreds of life-cast animals and plants in bronze, silver, tin, lead, plaster, many different kinds of media. It was a very much sought-after technique, and these objects were meant to provoke conversations in Renaissance Kunstkammern, where they were collected. They were supposed to provoke conversations about the interplay of human art and artifice, the human artifice and created nature, and the artifice of nature. So these kinds of objects could could have many roles, really. They could prove rare and odd natural phenomena, such as the crippled and seven-fingered hands of peasants cast in plaster in the Bavarian Kunstkammer. They could stand in for the real objects that soon withered and died. And they could display the talent of the artist in producing fine molds and understanding the casting properties of metals. But they had a much more profound significance as well, because plants and these kinds of plants and insects that were especially cast called up ideas of metamorphosis and the transitory nature of the life cycle. Moreover, many of the animals cast from life were associated with spontaneous generation and material transformation, especially lizards, snakes, and frogs. These creatures, which appeared seemingly spontaneously from putrefying matter, lent support to the common sense principle that generation involved a process of decay that you can see, for example, in the germination of seeds. But lizards also regenerate their tails if detached. Snakes shed their skins. Adult frogs and turtles emerge from the ground after freezing winters. And living crustaceans were reported in the 17th and 18th centuries to be found alive in solid stone. Such creatures were approached ambivalently, on the one hand as impure and associated with putrefaction, yet as crucial in processes of transformation and generation, being used in birth amulets into even the 20th century. Lizards in particular appear to have had significance for metalworkers and were sometimes employed in metalworking recipes, including one in the Bibliothèque Nationale de France, manuscript France 640, our manuscript. They were used in metalworking recipes to produce gold and gold-colored, or ostensibly to produce gold and gold-colored pigments. Thus, the types of animals used most frequently for life casting were those that seemed to give the most insight into the processes of putrefaction, generation, regeneration, and perhaps ultimately into the question of what quickened living beings. Let me just show you an example of, no, I will not show you that example yet. Okay. So this manuscript is so interesting for reasons like that. This philosophical use of and construction of animals and plants, that I decided to study it more closely, the manuscript, in order to try to reconstruct, in order to try to understand the manuscript. So, as you saw, the manuscript is a very long manuscript. It's 170 folios. It is very complex, lots of marginalia, lots of rethinking, lots of trying out different things, lots of notes to the author, practitioner himself. And so when I tried to read the sections on casting from life, I really couldn't make head or tail of them. And so I realized that I really had to reconstruct the process in order to understand it. And reconstruction is a kind of, it gives you a technical knowledge, and technical knowledge is a kind of literacy. And the way to obtain it is to do these kinds of reconstructions. Now, this is not a reconstruction in which you just go into a lab and start making, although that does kind of describe the way we started it. But it is you have to work with objects, such as museum objects. You have to do a lot of work in texts, such as these compilations of technical recipes that are often called books of secrets, like this one, or Vannoccio Biringuccio's Pyrotechnia, and illustrations like this of the goldsmith's workshop by a practicing goldsmith. And then, of course, with this manuscript. And it is a process, really, we found, of reverse engineering. That is, the manuscript author worked very hard and laboriously, as is clear from his text, to put his actions and his making processes into words. And we are using his words to try to reconstruct those making processes. So it's really a process, it's kind of an odd process of reverse engineering, but it's really, I think, the only way to get this technical literacy. And I think that technical literacy is very important for people who are working on objects and in early modern Europe. Okay, so what I want to do is show you I'm going to click through the, I'm going to click very quickly through the processes of life casting, and you can ask me more about it later. The one thing we did not reconstruct with this life casting, this reconstruction process, is in fact what is listed or what is described in the manuscript, which is catching, feeding, keeping, and killing the animals, okay? So turns out that actually catching the animals with a slip knot, with a little stick and a slip knot, and holding it over the lizard's head and whistling is the way that herpetologists catch lizards today. So I just wanted to show you very briefly how that works. So you just slip it around the neck, and you got it. Okay, so if we could go back to the PowerPoint. Thank you. Oops. So I'm just going to show you very quickly some of the things that we realized. You can see this wonderful sketch on the right, which is a detail of the page about lizard, one of the several places where lizard casting is described, but this is the only place that there's this wonderful sketch, and it shows you the way that the gate goes into the mold here and attaches to the tail right here. And then the metal flows through the mold, or this is how we imagined it. It flows through the mold, the body, the burned out body of the creature acting really as one of the main channel for the metal to go through. This is our reconstruction. And we know that it was done, that objects from the 16th century were cast through the tail, because here is an example. I'm sorry about the quality of this. Here's an example of the gate. The gate is right here. It's been filed off. And here's a close-up. It's not much better, but you can see the gate there. That's a different lizard, cast lizard. And you can also see the casting of other delicate objects through the stem, like this 3-inch high buttercup from the Germanisches Nationalmuseum. And then they also described very usefully is the method of pinning the animal to the base so that it doesn't float up to the clay base, and then taking out the pins. Okay, this was our first lizard reconstruction, which was very messy. You can see the lizard in there. It was awful. Basically, we had no idea what we were doing. It was our only one of 2 lizards. This is what it should have looked like. But we did improve at the end. So I'm just going to page through these to show you the casting process from life. We have the text, we have the object, a 16th century object. We have our crayfish. And you can see here that, again, the gate is going to be here. Here are the sprues going into the claws. And here are the risers that are going to let the gases out as the metal flows through the body of the crayfish and through those sprues. Okay, so I'm just going to page through these, and you can ask questions. I'm setting up Andrew's experiments with this. Pour in the first half. It's a 2-piece mold, so we poured the first half, let it set. Using the recipe in the manuscript, we turn it over, we pull off the clay base that exposes the crayfish, put the wall back around it, and then you pour the second half. Then you're ready to burn out the crayfish and melt the wax. And this is what happens when you burn out the crayfish. You get these very little ash, actually. And then you press it together. Here we are doing reconstructions at Williamsburg using charcoal and as the heat source. And then we open up the crayfish, and we have a pretty nice, it's a silver lead mix. This is also a silver lead mix, but was poured too hot. But still, we got quite remarkable detail. And finally, I just wanted to show you one of our best casts on the left, and you can compare it to the rhinoceros beetle on the riding casket from Vienna. Okay, so this whole process of reconstruction for me, oh dear, it's going automatically, was really gave me at least an exposure to the technical literacy. I would say that my level of technical literacy will always be low because I started so late. But still, it gives me an ability to understand materials and techniques, and also the texts I read in a much different way. So I decided that this was such a valuable experience, and of course I work with students who are working on craft, are working on art history, and so I wanted to give them that exposure too. And you know, these are students in history and history of science, in art history. Of course, there are many other programs, archaeology, art conservation, which do this kind of thing, train people really properly in reconstruction. But I think that it's very valuable for general historians and art historians as well. So I founded the Making and Knowing Project, which has 3 components. It is, the goal of the whole thing is to produce a critical edition and translation of this 16th century manuscript. And in order to do that, it needs to be properly transcribed and translated, which we do through a paleography, summer paleography class in which students gain about 15 to 17 students. We're going to have the second annual one in June, work on certain folios of the manuscript. Last summer they did almost all the metalworking folios in the manuscript. This coming summer they'll do color making. The manuscript has a lot on making colors, coloring wood, metal, pigments, textiles, how to paint, etc. So all of those ones we'll do this coming summer. And here's the French paleography workshop last summer. It was quite an intense and wonderful experience. And they did, in fact, could we go to the, they did, in fact, transcribe and translate about a third of the manuscript. Not that one, it's the, you have to close that, or maybe I have to close that. No, do you have, no, I guess I close it, right? Yeah. Okay, so, where's the, then there should be the Google Drive, is it not? Is that it? No? No, okay. Well, anyway, we work collaboratively and collectively in a Google Drive in which we can all work at the same time. It's a not very good platform for doing collective work, but it's the best and the simplest that we've found so far. And it's a wonderful experience, actually, to have. We now have something like 137 collaborators on it who are at least able to view it. Only the paleography and the editors can, in fact, edit it. But we're getting through it, and we're getting through it actually very quickly. So the second component of the Making and Knowing project is the laboratory seminar, in which students take a course that I give every semester. I co-teach it with the postdoctoral fellows at Columbia. I have 3 postdoctoral fellows on the Making and Knowing project. And we have expert resident makers come in for 2 weeks at a time each semester. And this year we're doing metals and metalworking, and next year we'll do color making. It's actually, I call it metals and metalworking, but that's totally wrong. It's actually mold making. It's all about mold making, because metalworking is in fact all about mold making. Okay, so you can see that we have both discussions in the lab, and we also do a lot of skill building to start out with. We start out with historical culinary recipe reconstruction, which is great fun. I recommend it to everybody as the first class. And then we move on to the manuscript, in which they make bread molds, as is, there are a couple of recipes for bread molds in the manuscript. And they have to learn how to make bread, and they have to, then we cast tallow, wax, sulfur, so they get to know some materials and properties of materials. And then we move along on to sand casting portrait metals, which are also recipes in the manuscript. There are about 80 different recipes for sands, the sands and binders in the manuscript. We archive everything that they do. They have to take very detailed field notes on everything they do, and upload it to a wiki. So they all have, copious field notes, which then which allow them to, they choose 3 recipes which they write annotations on. And I'm going to show you some examples of the work that they've done in the class. So some of the things that last semester is the first time we taught this course. Some of the things that the Reconstruction has taught us, it's made very clear to us that the manuscript is the result of workshop practice, and is in fact an account of someone working in a workshop. It has helped us decipher recipes, it has helped us decipher techniques, it has told us about the behavior of materials, it's given us knowledge of the nature of experiential knowledge, and it has told us a lot about the material imaginary of the craftsperson, and that's what I'm going to focus on. I'm going to finish up in just a couple minutes. So this is an interesting deciphering of recipes. We have this marginalia. We're trying to figure out what tri-oyster shells means, tri-burnt oysters means, whether it's in fact a binder or a sand. So the students they calcined the oyster shells. They tried to mold with them. The the material is, of course, quicklime, so it had this very hot exothermic reaction. So they tried it as a binder instead, and used one of the base of the binder, one of the recipes in the manuscript, went through this beautiful color change, and actually produced a very nice binder for sand and a nice object. This was trying to figure out, again, deciphering a recipe, the meaning of neat gold, and a particular flux that was used. And this one was very interesting, but we need to do it again because we'd have to really to figure out whether the verdigris which was used that you saw us making there was the active ingredient, so to speak, in making gold neat. It's also helped us decipher techniques, and I won't go into this. This is a wonderful one, very new and very unusual information on how to make what's called in-cues reverse casting, which is convex on one side, a portrait metal with a convex portrait on one side and a concave of the same thing on the other side. Anyway, there's a wonderful recipe in the manuscript, which is such a great example of artisanal shortcut on how to do something really simply and effectively. So I'm just going to go through these. We get to know about materials, especially the way in which the manuscript talks about the materials. And what it's told us is that, it would be a problem if we saw quantities in the manuscript, because in fact, quantities are less useful to us or to a person working in a 16th century workshop, because you really want to know about the consistencies, the end product. Right, and this is what we have come to see very clearly is one of the features of early modern recipes. So yes, we have lots of disasters, but that's simply part of the learning process, and I can tell you about these later. That is, in fact, just the nature of experiential knowledge. Okay, the material imaginary, and I'm going to end with this. So one of the most interesting things for me as a historian of science is, first of all, thinking about the methodology that Reconstruction, how we can both justify it as historical evidence, because it is, of course, something that one creates, and then you use it as historical evidence. So there's a methodological puzzle there, but we are trying to lay out a procedure for both teaching and writing using this kind of experiential knowledge, this subjective knowledge, in a convincing way, in a convincing scholarly way. So that's part of the challenge for me in particular, is to try and articulate this methodology of Reconstruction. Then the second most interesting thing for me is really finding out about the material imaginary of the craftsperson. And I started with that, telling you about casting from life. But I want to go on to tell you about the problem of red. So many manuscripts from this period, metalworking manuscripts, talk about using rusted red iron filings to make the material strong. So we were interested to know, is that a symbolic use of red materials? Because of course red was a very significant color, and anything red had a significance in especially metalworking processes, but also in a lot of other kinds of processes as well. It looks like blood, of course, and some of the people here in the room tonight have argued that blood and bronze are related and that blood was implicated in metalworking recipes. You find that, in fact, blood is often added to metalworking or used in metalworking recipes. And red ingredients are often added to the materials in metalworking processes, even when they don't seem to have a particular role or they aren't an active ingredient. They are added in order to, possibly make the material strong, like the strength of blood. So we tried it out, and we found that. So here's an example of a very significant object, and this is the one that I was going to show you before, the philosophical object of the Daphne of Wenzel Jamnitzer. And the reason I show it here is because of this, the red coral, but I would argue that the whole object is in fact one of these epistemic objects, like life casting itself. And the reason I say that is because if you look right around the base, you can see that, this great thing is that it's a drinking cup. It's this 2-foot-high Daphne comes apart at the waist and is a drinking cup. So that's another part of the significance of this object. But what I want to show you now is around the base are these little mineral specimens. And some of them, like these, grow on shells. They're these little worm extrusions. Then there is mica, fool's gold. There is some marcasite or copper ore there. And there is some sulfur-containing mineral. And these are all stones which were understood to be part of generation, to show evidence of generation. And just one of the things in the manuscript, when he talks about grottos, he talks about grind in order to make your grotto, the wall. There are all kinds of things you use. You use parchment, you use coral, you use irregular pieces of wood. You grind in a little bit of marcasite with glue, and then you also grind in some sulfur, which is the start of all growing, as he says, and so some sulfur-containing mineral. So clearly sulfur-containing minerals were seen to be significant in terms of generation. And of course, in this Daphne, we see the way in which the gold and the metal flow up through as Daphne turns into a laurel tree to escape Apollo's unwanted attentions. And you can see that the hands are just turning into coral, and they are little cast from life leaves are springing from them, which is, the kind of beginning of all growth and transmutation. So red is very significant, as I said. Mercury cinnabar, mercury ore, mercury sulfide, vermilion. Artificial vermilion was was a process which could be seen as alchemical, and certainly the sublimation that took place that brought into being this red powder was used in paintings, especially for blood, and particularly for the blood of crucifixion in representing Jesus on the cross. Now, red was connected to gold because, as I said, red ingredients were specified in making red in gold pigments, and gold was used to produce red color, for example, in creating red lusterware, glaze, and in ruby glass. Moreover, when worn on the body, potable, or when drunk as potable gold, gold was seen to promote health and healing and to bring about a more sanguine temperament associated with the humor of blood. So that these early modern recipes like this manuscript, which specify rusted iron filings as an ingredient in mold material to make it strong, probably had all of these meanings in mind as they used it. But we found that it made this incredibly blood red color on our molds, and it did in fact make them harder, although we needed to test that really with a structural engineer or with a material scientist, which we did not have access to, so we'll have to do that again. But I just want to end with this. This is the first page of the manuscript, and it's very interesting. The first page of the manuscript is for counterfeit, or rather imitation coral, making imitation coral. And it has this cross at the top. Now, a cross often started a page in any text, actually. If you look at account books, at commonplace books, you find often that there's a cross at the beginning of a manuscript or a cross at the top of every page. So you're starting your new page under the sign of Jesus, of God. And this cross, there are other crosses in the manuscript, but they point to other places that you're supposed to go to find the rest of the marginalia. But this one doesn't point anywhere. It is on what seems to be the first page of the first actual starting page of the manuscript. And it's also at a point at which vermilion is used. And this cross was used by illuminators in medieval manuscripts to note where to add vermilion in a illumination. So, I don't know whether that's what it means here, but it just seems so significant that here we have this deep red. Here's an example of drops of Jesus' blood made with vermilion on the flyleaf of a 15th century Psalter. And here is the imitation coral that we made from the manuscript recipe. So this deep red blood, marked by the sign of the cross in the manuscript. So with that, I'm going to close, just giving you a taste of casting from life and of some of the philosophical objects and deeper kinds of things that you can get out of reconstruction. When you begin to investigate materials and techniques, you end up with things like imitation coral and its connections to blood, to crucifixion, to spiritual practices, etc. So I'm going to turn it over now to Andrew.
And this is working, and you can see that? That's great. I just want to say that the thing about disasters in a studio space, they're really important. Yeah. They are so important. And it's not just, as long as no one gets hurt, that's okay, right? That's the key thing. But if you don't have the disasters at each end of the process, you're really not learning anything. So it's like if you recreate something and you do it perfectly every time, we've learned nothing. So you need those really big disasters. Hopefully that are pretty safe. Now, I just wanted to say that, just to explain where my thinking's coming from, my kind of background. On the one hand, I'm an artist and sculptor, primarily a sculptor. And the unusual thing is that I've always had my own bronze foundry. Okay, so I've always had my own bronze foundry for the last 25 years, thereabouts. But at some midpoint, I went back to study material science, in particular archaeometallurgy. And then that got me onto a kind of scientific route. And so now I do a lot of recreating, experimental recreating of these sort of objects. And the common point is, whether I'm doing the X-radiography, or whether I'm doing the recreating, or whether I'm sculpting my own thing from my own sculpture process, they all center around the furnace. And what I've ended up doing, Sean and I, we have this particularly unusual studio space in Devon. And it's a large kind of medieval-looking barn. It's about the size of a church. It's huge, and it's got a really big yard to it as well. So it's a wonderful space to do these things. There are a few modern materials and a few modern bits of equipment, but mostly it would be something that would fit into 15th, 16th century kind of landscape. And so what I've ended up finding is that when I start to work with someone like Pamela, I learn so much. I learn so much, and I see so many things. I'm kind of reading this manuscript and kind of plucking, as a kind of artist magpie. You end up plucking loads of wonderful ideas. You think, yeah, this is wonderful. I use it. I can keep that for later. But I can weave it all together into that studio space. So it's like a constant feedback. Whatever I'm researching, I try it out. I can understand it, see if I can apply it, because the great thing is if I apply it to my own sculptural work and then keep the experiment going, even though it's for a commercial, there's a piece that's going to a gallery or going to a show, some of that work will tell me more about a material that I'm not familiar with. And the other thing I just wanted to say is just the whole thing about experimental recreation of these processes or these objects usually happens because a conservator somewhere in one of the museums has looked at a piece, there's deep curiosity, has done lots of analysis, and it's from that data, that material, that I often get asked, well, what does that mean, or why is that, how do we put that together? And so then I recreate the whole process. And there's an interesting thing, you have to kind of split your mind. So I said this to the students yesterday. Split your mind. Keep one half of it in the 21st century, which is where you're going to take all the measurements and do all the analysis. The other half, really step into that period and that place and think about and consider not just what you're doing and the material kind of context of it, but what's the extended context. Who's it for? Who am I making this for? What's the situation? What's the environment? The location? Everything. So it's easier to do it as an act. It's almost like being a performer. So in a way, I kind of call it a reenactment process. It's shifting a little bit. And the other thing, my goal in one sense is to elucidate what the processes are and the materials are doing, so we can map them out and pin them to things that we find in the analysis at the end. But the other thing, which I'm really interested in, and it's hugely speculative, is this idea that you can get into the mindset of the artist or the maker. And there's no real good evidence for why that should happen, but there are things that come up, and particularly looking, in this case, because we're looking at a manuscript where so many of the pages, and we're going to be looking at life casting of lizards after this, so many of the thought processes are written down, and they're often really good when they're in tiny little diagrams, where on one page there's a diagram which kind of says this is how this should be done. On the second page there's an amendment, and really actually it's better if we do it this way. And so we start to think, this is a kind of long ways process of how he's thinking, but it's great, or he, she is thinking. So that's my real goal with this, get into the mind. So let's just see. Ta-da. Now, I didn't catch this one, so I didn't go out with a noose to get this one. This was really, really lovely. It's really difficult to get material like this, get lizards like this, ethically. Okay, and particularly in England, because we only have a couple of lizards in type, and they're both conserved. They're very precious things. But Sean and I, we both went into a pet shop, and Sean just said, "Do you have any dead lizards? Do you have any dead lizards?" And it's like, but why would you have dead lizards in the pet shop? It's the weirdest thing to us. We say, okay, we've got one. And the thing that happened was that this pet shop donated a lizard to a school. The school looked after it, cherished it, really, kept it wonderfully, and then went on holiday for the summer holiday. I forgot about it. Yeah, really. And so when they came back, they were like, "Oh, it's dead." And so they returned it, and they couldn't understand why it's not moving. They said, "Well, yeah, it really is dead." And so the pet shop took it back, and it was stuck in the freezer. And so when we turned up, this person said, "Yeah, we've got this thing. Would this work for you?" So we have this lizard that was absolutely wonderful, quite pristine, if slightly saggy around, the midwest. And it, it's quite an unfortunate thing. Actually, if
the manuscript says, "Be sure to feed
Yeah.
your lizard, otherwise it will look desiccated."
And it did a bit, I have to say. I mean, it really is a little bit poorly. Sean, could you actually pass around the two lizard bronzes? So there are castings which are coming around, which we'll see later, but it's good to see the size of this one. Okay, so this is the lizard. Now, this was commissioned as a handling object by the V&A. So this is before Pamela invited me to work with her on this particular project. And it was done just last year, and the goal was only to get a handling object. And I didn't realize, or I hadn't read any of the text that Pamela's been working on. And so I was working with a slight amount of knowledge, but a lot of guesswork. And so the sequence broadly describes what Pamela's been working on, but there are some deviations. And there's also some deliberate deviations because I like to push the boundaries of what we're looking at. So lizard gets put onto a bit of clay. And then lizard is encased in this ring of clay just to build up a wall. Okay? And you see all the sprue system there, and in this case, I got it wrong. So, but what I was trying to do is figure out, well, do we need sprues that are made out of wax? Can we use sprues that are made out of clay? Does it have to be done in a certain way? Because I was trying to think through variations on this process. So, but what I did do is a pretty good interpretation of the small little diagram that's in the book, apart from it's inverted, the metal is going to be coming in. You see there's a cone shape at the top. So that's the ingate, so that's where the metal's going to come into. And really and truly, this particular person is working the opposite way around. Doesn't matter for now. The next stage is to splatter it, really splatter it with plaster. And it looks a bit archaic. It's a plaster that's a basic, really basic plaster of Paris. So it doesn't have any special qualities to it. It's quite simple. It's not super hard. It's not highly refined. It's something I use regularly in the studio. And that's mixed with a sand that was really a river sand, local river sand, 50-50 mix. And the reason why it's splattered like that is that if you flick it onto the surface, it knocks the air out of the surface, knocks the air bubbles out, and penetrates closer in so that you can actually get a crisper casting. So then, whilst that's still damp, and you only have a few minutes, I mean the setting time of plaster can be extended, but generally speaking, it's a short, 5 to 10 minutes maximum. So I made up another batch, filled it full to the top. So that makes 1/2 of the mould. And then take the clay away, reveal the underside, and you can see the lizards there. The sprue system is still there, but that was all dug out later. So that's just the reverse side of it. And I've also made some notches so these little hollows on the side, little finger-sized hollows, are just to locate 1/2 of the mould to the other half of the mould. Right? So there's something that makes sure that everything's registered together. And so then if we build another clay wall around that, build it up high enough, and then we'll do the same process again on the other side of the mould. We flick on, get it tightly bonded to the surface, grab all that detail, and then fill it up right to the top. Each half of the mould is about 1.5 inches, 2 inches thick, which is really important because if it's any less, it's too fragile. I find that they really are problematic. It causes another problem later having them that thick, which we will see. So this is opening up the mould. And really and truly, I shouldn't have opened up the mould at this point. I should have just put it straight into the kiln and fired it. But I was curious to see whether I could retrieve the lizard. And I was thinking, well, maybe if I can retrieve the lizard, maybe I can use it again. You could be a multiple-use lizard. It's clearly not. Clearly not. He was so firmly stuck in there. It was just not going to happen. But all of the clay, which I thought might have been problematic, just pulled straight out. So there was no problem with that. So it was a valid, usable method with this process. And you can see the neat imprint on the other side of this. That is the underside of the lizard. It just worked beautifully. The notches on each half locate everything back together again. That mould goes back together again, put into a kiln and fired. And that was roughly where the bulk of the problem started. And in our studio, I have to say, there are no temperature guides. There's no temperature probes. I've got nothing for the wax. I've got nothing for the gas temperatures. There's nothing for the metal either. It's all done by eye. And it's just because I've got so used to doing it. I've got so used to just using that sensorial kind of gauge. You know, what's the smell of it, or what's the viscosity or the feeling or whatever. It's just using those senses and trying to get back into that mindset. So we're not solely reliant on the digital world. Now, the mold, when it came out, was pretty good condition. There are quite a few cracks in it. But you can see the lizard, what remains. Most of it's gone away. Some of the bones remained. And if I go to the next one, you can even see the little bones for the hands, or for the claws. And then the imprint beyond that. So it's incredibly fine. Most of this material just washes straight out. A lot of it doesn't, and is quite tenacious. So you do, at some point, have to open up the mold, or the other great method is to pour mercury in, slush it around, and allow that to catch everything out, take everything out. And even I'm not going to do that. I can take certain liberties, but I think I'm going to draw the line there. So we could open it up, and we can see these wonderful little things, but you have to remove everything. And there are points where you just can't see what's going on behind a certain point in the mold. And so you have to keep probing, blowing, pushing, getting little bellows to excavate the material. Because if it stays in there, it's tenacious, and it will just get into the bronze casting itself. So the next slide. Part of this recreation, I do have a gas furnace, but I also like to use as much as possible, particularly for things like this charcoal. The mold at this time has been bound back together again, is in another kiln, is heating up, so it's nice and warm. Simultaneously to this, bronze is being prepared in here. I make all the bronze myself. So it is a mixture of 10% tin bronze, and I put all raw materials in and use old materials as much as possible. So the tin that was used was actually an ingot from a ship that was found off the Cornish coast that's about 200 years old, which means that it's not just tin, it has all the other materials in it. Bismuth, arsenic, everything else that you could possibly not want to actually breathe in. And I'm just going to show you this. This is a really quick sequence, but it's the bit that's important. Because up till now, it's whether you're doing life casting or you're doing a sculpture itself. If you imagine, if you're making a sculpture in wax, little figurine, for instance, it may take a week, or it may take a couple of weeks, or it may take 3-4 weeks to get to that point, sprue it up, do a clay investment or plaster investment, and do it perfectly. Then when you come to the actual casting itself, it's seconds, absolute seconds maximum. So you imagine this, and then if we can flit, and you can see all the dross at the top of the crucible. There's lots of debris. I try and scrape off as much as material as possible. And for those seconds, that's actually longer than it takes for all that metal to go in. And the reason why that's important, because everything happens at that point. You know nothing about what actually goes on inside the mold. And so we've got the actual mold, or this is a similar mold, and a lot of charcoal and material that's floated to the top. Ta-da! And it's okay. It's not great, but it's one of those disaster moments where you think, well, it could have been finer. But generally speaking, there's some really good texture. And the whole of the lizard's there. What it meant for me is that the firing of the mold had not gone to plan. There was a little bit too much moisture still in there, which had expanded and exploded the outer surface of that mold. But also, it just means it's more work for me. And actually, it takes the detail was absolutely fantastic. I was so pleased with that, even though there's lots of flashing on it. You could remove all the flashing. And these are my regular day-to-day tools. One of those has a kind of square, pointed end to it with multiple little points, little pyramidal points. And I found that was wonderful in recreating the lizard scales. So I can go over the surface a lot, and to a point where you can see the little punctuation, the puncture marks of the tools. And in fact, as a handling object, this was horrible, because the points around the side of the jaws were so sharp that we ended up getting one of the conservators to take them all down because it was just, I mean, I was drawing blood on it. So it was partially successful, but you can see some of the fingers on the true right-hand claw had just disappeared, but the rest of them were actually quite successful. So you've seen this manuscript page again, and this is what was wonderful for me, is to see not only the text and the thinking of what was going on, but also a diagram, because that diagram lays everything out, and particularly what I was interested in is how the metal was going to flow into the interior of it. What was great is that on the other side, you see there's a tiny little triangle with 3 little prongs sticking out the bottom of it, is the readapted ingate. If I go back to the first one, the ingate's at the bottom. You can see it as a little kind of a long cone and a kind of more convoluted construction of pipes. These are the sprues. So it's where the metal's going to come in and everything's going to come out. This was the adaptation he thought that was going to make it better. And what was important for me was this bit. That artist or that maker was, in one hand, imagining what was invisible to him. So he was creating a kind of idea, a paradigm of what the metal would flow, how that would flow through the lizard, how that would flow through the mold, on the basis of what he had seen time and time again for all the castings, and the only evidence he's got is what comes out to the other end. There's nothing that he can see. Once the metal goes into through that tiny little hole at the top, that ingate, everything else is imaginary. So he's got nothing to witness, apart from the stuff that comes out at the end. But that can be deceptive. And it's not like you're pouring water into a cup or pouring water into a complex vessel, because water will stay liquid. The thing with bronze is it's going to be liquid slush, where you have crystals forming, solidus, possibly going back into a liquid state, forming different crystal phases, body-centered, cubic, face-centered cubic, all sorts of things which have different qualities to them. And then other things happen. Gases that are in the atmosphere, when the crucibles in the furnace get absorbed into that, when the metal solidifies, it comes out as bubbles, comes out as all sorts of different problematic things. There are tons and tons, literally hundreds of little flaws that could happen at that point. So on one hand, they're imagining what's invisible. On the other hand, I'm trying to image what's invisible. And so this was the really useful thing for me. I found a place, or a way in which we could do this. Now, so the next one is, I just want you to think, this is a sprue system on a bronze where they've kept the sprue system, is basically to show how great the technique was. It's Louis XIV sculpture. And just if we look at it, at the top you have that cup, and then you also have 4 runners that go all the way down to the bottom, and then on every stage, every few inches, there's a little bar that returns back upwards, and it's like a return feed. And so the idea is the metal runs down the main feed, circulates at the bottom, starts to rise up under pressure, and then every time there's another bar, another sprue feeding in that's raised up, the pressure is such that it goes in and then feeds that section. And so the idea is it's a controlled process of entering metal into that the artist can understand, where we're trying to control what happens at the later stages when it's cooling down and solidifying, so we get a great casting. There's a hole on the other side of it, which never gets photographed. The other bits to remember are the vents. And the vents take all the gases out. So when you think about a sprue system on something like this, 2 things have to happen paramount. Metal goes into the object itself, gases come out, so one displaces the other. So it just breathes naturally. If you don't, then you get air traps, and again, we have one of our natural disasters. And so what I did with the previous lizard, now that I knew what Pamela was kind of working on and examining her texts, I had, at that moment between the freezer and putting him into an investment mold, taken a rubber mold off of him, where I could take multiple waxes. And for me, that was, although it's not life casting per se, what I was looking at one particular question, which was how this person was thinking about the flow of the metal. Because for me, it was particularly peculiar. So I made these waxes, which are solid waxes, and I sprued it up this time much more closely to how he was imagining. So we have this cup at the top with this strange little three-pronged ingate, and he always suggests feeding something from the tail. And why that is particularly peculiar for me is that if you ask any foundryman now, they would say, oh no, you feed into the thickest part of the body. Really, that's what you want to do. You want to get the metal in there as quickly as possible. And then there's this thing that you have the cup at the top fills with bronze, and the body fills with bronze. And think of them as two separate reservoirs of bronze. And the thinnest bits of whatever is there, whether it's the sprues or the tail or the claws, are going to solidify quickest. So if they solidify quickest, and this person's expressing the desire, whether it's crayfish or a lizard, that we should sprue into the thinnest part, we have liquid at the top, a semi-freezing tail, and then the solid, the big thick section of the body, down here of the lizard, which is still liquid. So for me, that was really problematic, because why do that? Why do that? It doesn't really make sense, but obviously this person must have been successful, and we see successful castings. So somehow they got over the things that I was projecting into it. And just before I start that little thing, that was a teaser. The way that I can make this work so that I'm not just pouring metal in and then I get a wonderful casting that comes out at the end and think, wow, he was absolutely correct. There's a system where you can take an X-ray as a streaming X-ray onto a digital plate, digital pickup at the other side with your mold in between. So you can take an X-ray of it as a film, so it's continuously filming. And then at the same time, a robot arm, because you've got too many X-rays to do it with a person, lifts up the crucible, whatever bronze you desire, and pours it very precariously, really difficultly, so they're really expert people, these, into the mold. And you can see the actual flow of everything. Now, the people that did this, and it was really by their grace, because I'm sure it costs a fortune to do. It really must cost a fortune to do. Birmingham University, their metallurgy department were fantastic. And I think it took me about a year to get into this place. And it was basically because I wore them down with just enthusiasm, saying, oh, please, I've got a great idea. I'm sure it's going to work. And eventually, there was a previous experiment that I did with that. We did the experiment, and it was wonderful. It was kind of chaotic, but it was wonderful. And so they were absolutely brilliant about this. There are only 3 of these machines in the world. So they're very hard to get hold of. And the one that sponsors this machine is Rolls-Royce. And it's designed for their impeller blades and their jet engines. So it's really critical stuff. So to cut to the chase, we invested that. I invested that. It's a freestanding mold that's in between the X-ray and the detector. And then this happens. So this is in real time, as it happens. Ta-da! And you see, it really was just seconds. And so what we've done, Sean helped me with this, just slowing everything down and repeating it again. And you see, there's 2 things that immediately spring to mind. Pamela picked up on it immediately, which was really nice, is that the body, the tail of the lizard itself, is actually acting like a feed, like a sprue in its own right. And so the metal runs straight down to the bottom of it, enters the bottom of the mold, and then starts to backfill up. And the curious thing about this is it then becomes a bottom fed. This system is top fed because the metal enters at the top. But really and truly what's happening is a bottom fed, where all the metal goes into the bottom and then slowly rises up through the casting itself. And I'll just quickly show part of that again. Is the other thing was on the left-hand side of this, metal comes in, and you immediately see it go, and it spurts upwards, because there's so much pressure that it actually has to go somewhere, and so it goes upwards. And I've never seen liquids shoot upwards like that so fast in this particular manner. think of that bronze, the equestrian piece of the rider on the horse, and those neat little things going upwards. The mindset is that everything's going straight down to the bottom. I've made other castings beyond this one, and it's very clear that the pipe can fill, the body of the actual mold can stay empty for a certain while, but there's so much temporary pressure that actually backfeeds at midpoints and at high points. So it's totally counter to all the education that I've had and all the education that other people, other founders have had. You know, the idea's right, but actually it's manifestly wrong. It's manifestly wrong. And this is what's beautiful. This system of X-ray, real-time X-ray casting, it's an industrial thing, but there's, I think I'm the only person that's used it for art casting. And these are much, much, much more complex than a lot of the industrial castings that they're doing. So it's wonderful for them to see it. So to quickly move on, this is the resultant casting, which you've just had handing around. It looked great. There's a hole in the side, and I'll come to a reason why there's a hole in the side. I'm also thinking that the artist, when he was making these things, might have had some successes, might have had some failures, and enough time to repair or to discard. So what we end up with is very good examples and not necessarily the true nature of all the things that go through that technique. And then just to prove the other point, the reverse casting, so we've got it's top thread again, but this is how I would have originally thought about doing it, and that's why I did that first lizard that way round. And there's just a bit more of a three-dimensional thing, so you can see how it looks. So this is the second film, and it'll be the last film for this one, although there are many more that are coming after this. And again, it's quite chaotic. Those 3 feeds, because it's going into the open, the largest open section of the mold, actually spurt off in 3 different directions. They're doing completely counter things. There's no significant control there. And we see it slightly. So when I actually analyze these, I'm doing it frame by frame by frame, and there's a lot more information you can pull out about it, but it's too much for what we need to discuss here. And you can see the different densities as well. Just at some points you see the thinness and the actual splashing against the walls. And the other thing is, this process is great for this particular alloy. Try it with a brass, it may be disastrous. So it may not, it may be disastrous, I suspect it would be disastrous, because the splashing tends to oxidize rapidly on the surface, and so therefore causes an ugly kind of elephant hide surface to it. And that's the final casting from that. Close up of the detail, really lovely detail, captured everything. I took a standard X-ray of this so we could see things in more detail. I'm just going to move on to the next one. This shows it slightly better. The one that really caught my eye was this one on the left-hand side. So this is the tail-fed one. And what's particularly peculiar about it is you see in the tail, there's a dark patch, there's a dark circle. And then below it, there's another dark kind of elongated oval that penetrates out the side of the body. There's a bigger one, even messier. And then below that, at a slightly further distance, there's a crack. Now what's happening there is, as the metal enters in, fills up the whole body, the dynamic situation that happens with the bronze as it's cooling down means that the tail is solidifying, the last bit of liquid material is now in the body, and these points are vacuums that form as the metal starts to contract. And we see one followed by a short reprieve, another reprieve, starts to solidify, and we get the tearing inside where you get this kind of semi-dendritic kind of material that's there. If it didn't actually puncture the surface of the bronze, it would have been perfect and we would have known nothing about it. So it's really nice to sort of overlap lots of different methods of analysis. That's a snake, which I intend casting next. Another snake, just to show the complexity of flow, because it's so hard. And some of these, when you think about life, real life casting, you want to imbue it with something that's really powerful and has movement and sensation to it, not just a static pose. And then part that I wanted to say, I've learned so much from these processes. This is a piece by Sian. We collaborated, but it's really Sian's piece. It's Nature Tableau is the title. And it's because it's a table, but it's a tableau, and it's all life cast. All of the branches, all the legs, and the raised elements, all life cast with real pieces of wood. I can show you detail. You can see the structure of that wood, how fine it is. Life cast feathers, leaves, incredibly detailed fine casting surface. And then there's a super fine casting of just what would basically be the forest floor and the different materials put into it. So again, as artists, we've scavenged all these things and found it absolutely fascinating. And I just wanted to, but there's one piece that I was wanting to show today, and it's to do with, think of these things that we've seen not as just decorative pieces. They have a symbolism that's really deep. And they're powerful things. They're not just decorative pieces. And for me, I've been working on a piece for a particular artist in response to them. And they're a good friend of ours. This is a person called Ozzy Rees-Osmond, who's a fantastic Welsh painter. And he's also a bard, funny enough. He's bard of the Eisteddfod. He's a poet, he's a writer, he's just a great cultural activist, brilliant person. He's also terribly ill. And so when we came here, we left him. And that will probably be the last time that we see him. So for me, it's incredibly poignant. And as a response to his work, I've been working on a series of bells which are just to do with him. The bells are cast after Theophilus Presbyter, who's someone of the 12th century. So they're cast exactly after him. On top of that, there's a hawk. Ozzy's name as a bard is Hebog, which is Welsh for hawk. And so I've started to weave together a life casting of a sparrowhawk, which is incredibly complex, and I'm kind of not looking forward to actually trying to pull it off. The bell itself, and then there's material on top of the bell which relates to the whirler, which is the area where he paints so often, and it looks across to Larne, which is where Dylan Thomas used to live. So it's one bard to another bard. Liking the process, I would have shown you, but it's just a little bit too awkward a time. But it's just to say how much it is important to think of these as objects with depth and meaning. So I'll come back another time and I'll show you the object. It'll be another exhibition or something at some point. So that's the end of mine. Okay.
Good. Well, thank you both very much for this completely stunning presentation, each of which was, to me, really informative and resonant as well, and complementary. I think this way in which you work together is something that I'm very curious about, and I wonder if you have observations so far in your collaboration, which I know is going to develop further and has you've started working together. If you have some initial questions for one another as a result of what you've been doing together so far.
Well, I had to hold myself back from keeping saying, oh, in the manuscript it says, do it this way, do it that way, you know, and with the bells at the end. So this manuscript probably comes from the south of France. There are lots of references to getting your materials in places around Toulouse. And I've just found out from an art historian, they are a metal specialist, that there is a specialist in the 16th century in bell making around Toulouse, and his bells all have a little cast, a lizard cast from life on them. Yeah, I should have shown a picture of it, but that is just one of the things that I want to, wait, I know something that I can tell you from the manuscript about that.
Well, I think this is it. I've got so much to learn, so many things.
Oh, I have so much to learn.
to weave into it. But then, it does all start to feed back, and
Yeah.
it starts to feed back into the same pot,
Yeah.
quite literally, into
Yeah.
the same pot.
Yeah.
But
so many of the practices are similar. I mean, that's what amazes me. I think you're the first person that I've heard from when I was working on why metal workers ate butter in the 15th and 16th centuries before they did a pour, or before they went down in a mine, or before they began making vermilion. They were supposed to eat a big slice of bread with a big slice of butter on it. And you said, oh yeah, my master, or, my teacher told me I was supposed to drink a large glass of milk before I did a pour.
Yeah.
And so, there are so many practices which are actually carried over, like the lizard catching. And I feel like it's this, and you were talking yesterday about when you were doing the casting in the Jordanian desert, and you didn't know how to make, the furnace wasn't working, and so a shepherd came out of nowhere and told you how to make the furnace better because his grandfather or something had done it. And so, I feel like it's this whole underground body of knowledge, which surfaces just sometimes in texts, but is carried on by people like you. And I'm so tech-centric as trained as a historian, so I feel like there's this incredible body of knowledge which is just self-evident to you.
Well, it's kind of self-evident, but probably not. I mean, one of the things, we were having a conversation today. So there was Francesca Beva, Chan, and myself. We were having a conversation. One of the things that came up was actually the recording of material to do with everyday foundries from around the world. So really just thinking about, well, what's your practice? And rather than trying to describe it linguistically, just asking people, what do you do? Show me with your hands. And which is great, because it's like the diagrams, it speaks so much more. But the thing that also came up was, people would say things, I'd ask them a question, why do you do your casting in this particular way? What's the choreography? Why have you done it that way for so long? Well, because that's how we always do it. And you ask again, and you say, well, because the person I replaced did it, and then they put it, and what they couldn't express why they were doing so many things. It was just intuitive, or it had become so much part of their nature that they'd forgotten the rationale behind it. Yeah. But they had embodied it, and it was natural, and it works.
Yes.
Even though some of these things probably had a history that's way further than it was my master or my master's master. It actually went back centuries without them realizing the lineage that it had got.
Right. Yes.
Yeah, there's another example that we were talking about today, which is when I discovered that lizard catching is all over YouTube. And that's, something great about YouTube is that you can see so many of these practices, and you can get ideas about how they are done in different workshops. But anyway, there are lots of lizard catching recipes, and one of them is of an Italian an archaeological site in Italy, and there are two lizard catching teenagers kind of entertaining the tourists with their lizard catching. And so one of the tourists said, so where did you learn this this technique? And the Italian lizard catcher says, oh, it's a special secret of my grandfather's. And it's such a perfect example of the way that this body of knowledge, is kind of understood to be a couple of generations old. And I think that really tells us something about historical memory in general.
Yes. Well, I'm personally bursting with questions, but I'm going to hold back and open the floor to questions from, yes, at the back.
Donna.
Hi.
Hello.
I'm Donna Billick. I'm on the Methodologies project. And I was really struck by, when I was watching the X-ray, Andrew, I wonder if there's any relationship between this kind of spruing, or if there are innovations in this kind of spruing towards the end of the 16th century, and perhaps contemporary anatomical studies. Like I'm thinking of Vesalius and works that would then lead to more sort of investigations into cardio and pulmonary functions within the body, because it's the way it's set up, it's very arterial. And the castings that are happening towards the end of the 16th century are remarkably more complex than that which preceded it. So I wondered if you wanted to maybe weigh in on that or comment.
I'll make one comment, which is, thinking about that invisible moment. People like Leonardo da Vinci have been considering that for very much, before. So around 15, I think it's something like 15, 18, at that sort of period, he starts making drawings of how water's deflected by paddles. And what I've noticed is they make quite obvious things, because you see the surface of the water, but then he starts making drawings where he's speculating, you're seeing the bubbles underneath the surface of the water. So he's going deeper and penetrating in and thinking about the movements. And he's making, I wouldn't say mathematical kind of idea about it, but he's making a kind of structure that he knows that he can see that works, a way that fluid dynamics happens. And then later he's looking at the anatomy of the heart and the valves of the heart, and looking at how the blood would flow into one and then be pushed through, and there's these little vortexes that possibly happen. Now, of course, when he studied the heart, he's just looking at the structure. There's nothing actually within it. So it's a wonderful speculation of the nature of movement and fluid dynamics, which he actually got right, which I guess other people, like this particular person, were speculating equally and trying to get right. So,
yeah, I guess that, there were lots of things that you couldn't see inside of. The living human body was one, and the cast is another. And I think there's an obvious connection between veins in veins in the body and sprues. And Francesca Baber has written a wonderful article that we just read in class, which argues that Adrien de Vries actually, fed his sprues directly into the veins of the Hercules that he was casting in such a beautiful, flow of metal and blood. And so I think that there is, in general, a real kind of consonance between metals and materials in general, not just metals, but especially metals and the human body. And we see it in all kinds of ways in which you treat metals, you remedy metals in the same way that you remedy and bring back into balance the human body also in medical understanding at the time. So I think that there's much more of a continuum in general among natural materials and the human being.
Mm-hmm. More other questions? Andrew, yes.
A question about the manuscript itself and the degree to which it is an ongoing series of experiments.
So, yes.
And then the second thing I just wanted to ask is have you come across any biographical evidence about the man? Is he a goldsmith?
Okay, so all interesting questions, which if I could go on, and I did have a whole section on both of those things, but wouldn't have time. So experimentation. I think that, this manuscript is about constant experimentation. Just constant, and ideas for how to do things, and try burnt oyster shells, in the margin it says, or, try this in another point. And, yeah, you look like...
Is there a sense of experiments coming to fruition?
So it's not linear enough. Definitely you do it one time, you do it another time. And he says something like, yesterday I tried 4 kinds of sand, sand being the dry material for box mold casting. And so he's trying lots of things. Now, he does seem to come to some conclusions, but it's not at all written out in a methodical way. It's very, very hard to follow. And, there's a whole section on crayfish casting, and then there's another whole section on crayfish casting. So, the question is, how was this manuscript compiled? And it could have been compiled as, the methodical working through in a workshop. I don't think that's the way it was done. I think that probably he was collecting recipes as well as working with his own recipes, and that he would try them out as he collected them, and that he compiled them. And that this is probably, this doesn't have any marks of the workshop on it, this draft. I think it was probably a draft for a Book of Secrets. And we even have clues that this Book of Secrets might have been called La Boutique, the workshop, because he has almost a preface at the beginning, not at the beginning, like on page 100, folio 166R, he has a, something that's like collecting some kinds of Latin tags. He does know Latin, but it's faulty Latin. He quotes wrongly from books in Latin. So you know, he could be an ambitious craftsperson, like somebody that's actually mentioned in the manuscript, Jean Cousin, who did write and publish a book on perspective, a painter who was patronized by the same, was a client of the same Duc de Bethune, who also collected this manuscript. Okay, this manuscript is not by Jean Cousin, but it's clearly it's associated with the same old noble who was the envoy to Rome, who actually he bought Caravaggio's also in Rome. So clearly someone interested in art, and he collected this manuscript, and then it went into it was donated to the Royal Library with all of his other books in the early 17th century. So there's a biographical clue right there, right? But some of the other biographical clues are that he talks about some professions like tinsmiths and potters, and so as though he's not one of them. He also talks about his goldsmith's furnace. He tried this out in his goldsmith's furnace. He also has this very careful knowledge of jewels. You see, I think he was a jeweler, and lots of recipes for imitation gems and semi-precious stones. So my hunch at the moment is that he's a jeweler. The instructor of the paleography course, Mark Smith, who is a professor of paleography at the École des Chartes in Paris, thinks that he definitely wanted to call this thing La Boutique, and that the 166R is all about the preface that he was going to write for La Boutique. So those are the clues we have. We have, it gives us lots of insight also into daily life, wonderful insight into daily life practices. For example, did anybody here know that apothecaries used a metal that rang louder than people who wanted mortars to make mortars for their domestic domestic spaces for their houses, because apothecaries wanted to attract business by the noise they made. So that's in the manuscript, that apothecaries make it of a metal which will ring louder. So there are all kinds of things like that. Now, your second question, did I answer both questions? I probably answered more than your two questions too fully.
I guess one of the reasons I ask is that it's dated late 16th century.
Yes, correct. So there are dates in it. The canceled bill is used for paper for writing down a recipe on the other side, and that's dated 1580. So that we know that it was sometime between 1580 and when it was donated to the Royal Library, which was 1624, I think. I think it's 1624.
I just wonder if a goldsmith, would it be part of the training of a goldsmith by that time to be casting from life? Or how extraordinary would it be?
I don't think it's very extraordinary to cast from life, actually, at this time. Because Hugh Platt talks about casting from life. There were Wittelsbach dukes who were casting from life, princes, Wittelsbach children of dukes who were casting from life, as Dorothea Beamer has shown.
Sure.
And there were just so many life cast objects, most of which are lost in noble collections in Kunstkammer.
So I just wondered, does it tell you anything about the author that he is experimenting with it?
Yes, well, it could be an amateur, right? It could be somebody who's a collector, but he's so practiced. I mean, but why would he, if he's a practicing artisan, practicing jeweler, why would he have the time to write these things down in such detail? So that's one of the things that the students what the students are doing in the lab classes is taking a folio or taking a recipe, a technical recipe, and they are trying to investigate it from certain angles. And one of the angles is, of course, biographical clues. And then they write annotations on that recipe that will go into the final critical edition. So we have a lot of clues, biographical clues, but they're really small at this point. We have a lot of work to do in Toulouse still, because he clearly is working in Toulouse, so it's not as though he's in Paris. It used to be considered a Parisian goldsmith's manuscript, but I think that's completely wrong. One thing I want to say about experiment, which you could probably say something too, is that, so I think, this long existing practice, this kind of underground knowledge, and just human activity has gone on forever, and that, that's how we got bronze casting, that's how we got glass making. I mean, those are entirely artificial substances, and, made by human beings engaging in the material world, engaging with materials in an experimental way, and just trying things out that are around them. And any craft treatise talks about this. Use the materials around you, improvise. That's the whole point about getting experiential knowledge, is to be able to use materials in a very improvisational way. And that, you have this body of practice, of human practice that, emerges with the cultivation of plants and animals, right? That also is an experimental engagement with the materials of nature. You have it in the craft laboratory, in craft laboratories everywhere. This text is a manifestation of that constant human activity. And in the present day, we have it in science laboratories. I mean, that it is this human engagement with the material, very long term, and something that I think is characteristic of human beings, and probably gives human beings a evolutionary advantage in some ways. Also, the ability to manipulate natural materials.
I think there's another thing to add possibly, is that we tend to learn because we're taught by someone. We have a teacher that gives us this information, and quite often this is a lineage that runs down through centuries and all sorts of different periods of time. But there's also a thing of listening to the material. And so if you were in complete isolation, I always think of this, you've got this blossoming of metallurgy that wells up in the kind of the Middle East, that fertile crescent of the Levant, and then, in other places as well, and then spreads out across the world. Apart from in South America, where it's independently evolves its own route. But so many of the processes have parallels that happen in Mesopotamia or in different locations, because there are only so many things, or rather there's a language that the materials want. There's things that they can do, and it gets repeated.
Right. I mean, materials have properties. Now, human beings always are trying to overcome those properties or use those properties in new ways. But materials do have properties which train humans to develop certain skills. I mean,
but we have to listen to those. And quite often
exactly.
We impose things upon them, and not really engage with what it's actually telling us. And I don't want to be negative about this, but it's probably something that we're losing as things become more and more digitized. Is that language, vernacular, the way of communicating with that dialogue with materials and process. And we're becoming possibly less confident about it. So.
Well, that's one of the things that I really want to try to engender in this class, is to have the students develop this sympathy for materials. Now, what I mean by that is, coming to be able to think about what are the properties, to feel the properties of the material, to begin to develop a language in which to describe the properties that they are encountering, the resistances and the affordances of materials that they're encountering.
Well, there's something that you said yesterday in class, which was absolutely spot on, and it was like the recipe is important. Don't get me wrong, the recipe is important. It is not as important as the consistency of the material.
The quantity. The quantity is not as important as the consistency.
That's it. And that was a real, that's a real separation of mindsets.
Yeah, exactly. Yeah. Because we see a consistency so much throughout the manuscript. There's all kinds of description of consistency. Sorry, so weird. I'm going on and on. Are there other questions?
Yeah, Francesca.
Question, since you're wondering what the source of some of the information is, whether you've noticed a range of ways of describing things that might, maybe is the vocabulary quite standard in the way he describes things, or is there evidence that maybe somebody else was feeding him some information and that there's a different sensitivity to some of the materials or processes that are being integrated? I'm just curious. I mean, we were talking about standardization of vocabulary even today to describe certain things, whether, there's a playing around with that, or does it really seem very grounded in experienced knowledge the terrain that this person is describing.
Right, it seems really based in experienced knowledge, and one of the things that we're trying to do is figure out the recipe genealogies for the recipes that are in the manuscript, and so far we haven't come up with anything. Now, there may be more in the pigment recipes, but in the metalworking, there are many of the same materials that are being used, say, by Biringuccio or by Cellini, and the experimentation with binders and sands, with powders and binders, is the same as in those other technical writings, but there's so much more evidence of experimentation, on the page, in this written version, than you find in either Biringuccio or in Cellini. Those have different purposes, those published books, but it's striking how little relationship it seems to have to anything. It has a list of titles on the front page. It's not clear what the front page, before the 3R where the coral, imitation coral is, but there's a list of authors, and Palissy is mentioned, actually. And Palissy is mentioned by the title on one of his books. So it's clear that he had access to that book. Yeah, and it's in the same handwriting as the rest of the manuscript, that first page. So, it's obviously an ambitious craftsperson, if it's a craftsperson. He's learned, like Jean Cousin went to a couple of years of university, so obviously had grammar school and then went to a couple of years of university. So, he's a really upwardly mobile artist.
Yes, Christine.
I wanted to thank you both for your talks and Andrew's point about the material itself and thinking about sort of the sensory and visceral experiences and how that changes. Just some potpourri experiments for the survey class last week, just the layering of the sense, how the ingredients change one another and how it changes as you go on is so important, I think, to the process. But I guess that leads to my question. So we have successes and failures based on, let's say, Yamnitz or Palissy, where we have these tangible objects in museum collections. And what are the implications of such reconstruction methods toward things like your culinary, and some we've done with Professor Crone here, where we don't have something to gauge whether it was successful or failure, or how do we know if we've done the right thing or if we followed it, or what can we learn from that process?
That's so good. That is problematic. Yeah, because there's no end point, so you don't know how to reference it, whether it's good or not. Apart from whether it maybe tastes fantastic. That might have been. Yeah, was it edible?
Well, the potpourri not so much.
Okay, fine.
Smellable. But just thinking about some of our culinary experiments, that they might have looked not right, or sometimes they taste horrible, or sometimes they taste good, but what?
I have to say, so yes, this was fantastic. So, the culinary stuff, this is so fantastic, and I don't really expect our students to be able to do it in a kind of authentic way, because we don't have the tools, and we don't really know what a chicken was like in 1560,
I have somebody who raises heritage breeds who will tell you what a chicken was like in 1560. Let me tell you, there is so much local knowledge out there about, or at least faux local knowledge, I don't know.
In a sense, what I'm trying to do with my students is to see this as a way of reading the text closely, to try and interpret the text, and to de-emphasize the product, because we don't, we're not going to go and find the heritage chickens. That's not really part of our program at the BGC. I would love to do that in some other context, but we can't really do that here. We don't even have an oven in the building. So
they do theirs at home in our class.
Right, they do these things at home.
No, you're right. It's about the process. It's not about the product, and that's why it's skill building, because it's about learning to read a recipe, coming to understand what decisions you're going to make about what you're going to leave out or you're going to substitute, and how to do that in a methodical way so that it introduces them to the process of doing a reconstruction. And it's fun.
And understanding where the gaps are.
Yeah.
That's really that you have this list of instructions, and yet there's so much that's not written down. So I think Andrew's experience, as I know it with metalworking, is extremely important, because there's probably a lot of stuff that's left out of your manuscript too, just, details, and trying that you fill it in almost unconsciously with your own experience.
Well, one of the things that comes up is the recreating of these experiments, and particularly the really complex ones that I've been trying to do. They're only the beginning point, and I have to hold them very, very lightly. It's not total proof positive over this is exactly how something's done. And it's very much, really is very much the beginner's mind with this. I've been doing this for 25 years, so I'm reasonably good. And then I look at some of the stuff that I've just seen on the screen and say, oh, I just want to give up. It's so annoying. And so I can see the difference between what I'm able to do and Yamnitster's able to do. And it's just so far. I can have glimpses, but that's the thing that makes it useful, is I know what the difference is and the distance between me and that person is. And I just hold it lightly, but it's the questions which arise because of that. And you only really get to do that by going through the experiment, going through the process, and say, well, I just don't understand. What are they talking about? Why are they doing it this way? And why such? So it's a constant re-examination again and again and again, and there's probably no end point to it. It's just something that has to be revisited so often.
But sorry.
No, go ahead.
Oh, I was going to say that if you feel like you're only just getting there. We in our class, and of course me in particular, are just kind of being exposed to it. But what I've found, and because I also collaborated in the beginning on especially at the Rijksmuseum on the Yamnitzer, learning from the Yamnitzer piece with Tony Benches, who's a silversmith and the leader of the metals conservation program at the University of Amsterdam. And so what I found in working with him, it was so interesting. I'm very I was just trained as to use texts as evidence, and he is very interested in historical techniques and, reads the text carefully, but it was really interesting the way that he always filled in, and I thought way too fast, the processes, because he was very familiar with the processes in the manuscript, and I really wanted to go step by step so I could be sure to do it authentically. So it is true that, as I said, it's a literacy. Technique is, you have to become literate in techniques, and I still don't feel literate in techniques. I really need, to do these reconstructions, I really need people like you to fill in that technical literacy and to teach the students.
You've really highlighted one of the biggest problems, right, is as a 21st century person, even with a kind of an older mindset, you can't, I have to really rein back that urge to go, I can figure out what he's probably doing here and kind of fill in these gaps. Because if I do, I obliterate most of the evidence. Most of the idea or the process or anything that could have been there. And most particularly it's that thing of, well, this is an individual that's doing things in a very unusual way, perhaps. And those sort of idiosyncrasies I want to pick up on, I really want to find. Because that's the thing that's going to separate him from another person or another period or another space. And
the casting from the tail, I think, is one thing that was also very really counterintuitive to Tony.
Totally. And so when I did the first experiment, I used my intuition. This is how you should do it. But yours, I'm going to have to just give up, follow the recipe, and then be curious as to why something works or why something's been accepted. And I just see it. I do see it time and time and time again. Is that thing of people going, oh no, what you should do is you should do this. That's something they would have done. It's not appropriate. It's not okay. So it's being patient, I guess.
Well, and going back to the manuscript, that's what we find is that, so our first silver castings didn't work because we didn't take seriously that you really had to heat the mold red hot in order to make the silver run into that small opening. And then they worked, once we heated them red hot, cherry red. And we've just found that again and again. Some of the students, for example, found that they we didn't dry the molds enough, and then they went back to the manuscript, and there was a little drawing that showed how you were supposed to set the molds up above the charcoal, especially in order to dry them enough. And then one of the disasters was my mold walls collapsed when I poured in all the plaster, and there was my lizard, the only lizard we had, and I went back to the manuscript and it said, "Be sure to make your mold walls thick enough." So it's as we feel so much as though we're reproducing his experience also, which is a very which makes me think that maybe he wasn't an expert. So it's very mysterious and interesting.
Well, I think what we're seeing here is how the linguistic realm, in terms of the manuscript, and the extra-linguistic realm, in terms of the sort of transmitted practice and transmitted craft and art skills, are complementary, and you can't really grapple with them separately. And that's why I think this collaboration is so fascinating. And I don't know about all of you, but those amazing X-ray film clips that we saw made me think not only of the passage of molten metal into a mold, but also the pouring of wine into my mouth and beyond. And so what I would like to do is to thank our two presenters this evening, Pamela Smith and Andrew Lacey, and invite you all to go and pour some more wine into your esophagus, into the right bit, and enjoy the rest of the evening. And so many thanks.
Thank you.
Thank you.